In OpenFOAM version 6 we added 2 new scripts to enable more productive CFD by saving time for the user. The scripts are foamInfo and foamGet. I will demonstrate the scripts here using Window-Round Buildings tutorial case, which is already meshed. I'm going to configure some runtime post-processing of surfaces using the packaged function objects, which can be listed with postprocess -list. The long list of packaged tools is printed, and I can quickly find the surfaces tool that I'm interested in. To get more information about surfaces, I can use foamInfo. I simply run foamInfo surfaces. That lists various files with surfaces in their name. The tool prompts me to pick the file name relating to the function object, so I just hit enter. I can read the description of my surfaces configuration file, and to get a copy of it I can use foamGet. So I just run foamGet surfaces. It gives me 2 candidate files. One is the main package function object, the other is the underlying configuration file. I just hit enter to pick the main function object file. That file is copied into my system directory, and I can open it in an editor. Now I just want to configure it for one cutting plane, so I'll get rid of the X normal one. I'll keep the Y normal one, which I'll position to align with certain buildings in the geometry. I'll then get rid of the Z normal cutting plane and the ISO surfaces. On the patch surfaces, I'll just configure it for the buildings patch, and then I'll just save that file. I need to plug in that function object through the control dict file, so I'll edit that, go down to the functions subdictionary, and in there I can plug in my function object using the #include func directive. So I put the #include func surfaces there, which will pick up my surfaces file from the system directory. So I'll save control dict, and I want to run the case in parallel now, so I'm going to get hold of the configuration file to decompose the case. So that's decompose pardict. I use foamGet for that. It offers me 2 files. One is the least annotated, which is the one that I want. I choose that, it gets copied into my system directory. I now want to edit that configuration file, decompose pardict, and I want to run on 4 processes, so I need to change number of subdomains to 4, and I need to set for the particular method the coefficients, and I'll need to set that also to match, so I'll go for 2 and 2 to match up to 4. With that configured, I can now decompose the case, so I'll just run decompose par. That does the decomposition and splits the case to be on 4 domains, 4 subdomains. I now just want to run in parallel. I'll use MPI run, number of processes 4, running simple foam, redirecting to a log file. Once that starts running, I can just do a directory listing, and after a while the surfaces start to be written out to files, so I can see in post-processing surfaces at time 50 I've got some results, and then at time 100 as the code is running, and so on. If I want to have a quick look at some of those results, I could just read the files into ParaView. So open post-processing surfaces, I'll go to 150 there. I'll pick out the pressure on the buildings and the cutting plane with the velocity, hit apply, and now you can see my buildings and cutting plane. I'll colour the cutting plane by velocity, and we'll colour the buildings by pressure, and we've got some results. Maybe put a couple of colour bars on as well. So that's an example of using foamInfo and foamGet to get hold of files that we can use to configure our cases quickly and efficiently.